It's an idea that excites dreamers, storytellers, and scientists alike. Can we travel faster than light? Could there be shortcuts in space, like wormholes or folding bridges, that let us bypass the great distances between stars and galaxies? According to the math, it's not entirely impossible. General relativity does allow for such strange configurations. The equations permit concepts like Einstein-Rosen bridges, more commonly known as wormholes, which in theory could connect two distant regions of space-time in a blink. Imagine folding a piece of paper so 2 points touch, and then punching a tunnel between them. That's the visual metaphor. But turning that metaphor into reality? That's a much taller order. Even if wormholes or space folds are mathematically possible, they come with tremendous problems. Stability is a huge one. Wormholes are inherently unstable, likely to collapse the moment anything tries to pass through them. The only thing that might hold one open is something called exotic matter, a theoretical substance with negative mass or energy density. We haven't discovered exotic matter. We don't even know if it can exist. But without it, these bridges through space may be no more real than soap bubbles held together by hope. Even if you could build one, and that's a giant if, you wouldn't be breaking the speed of light. You'd just be taking a shortcut. The light beam still travels the longer path and reaches the destination in the time nature allows. You, however, would have slipped through a cosmic side street, reaching the finish line via detour. So, where does that leave us? After decades of clever ideas, simulations, and thought experiments, nothing with mass or information has ever been observed traveling faster than light. Not a spaceship, not a signal, not even a rumor. Every time we think we've discovered a loophole, the universe steps in, quietly, elegantly, and unyieldingly, with a chalkboard full of equations. It's as if nature smiles, raises an eyebrow, and says, "Nice try, but not quite." And maybe that's not a bad thing. The speed of light often feels like a locked door, a frustrating boundary at the edge of an imagination, a cosmic no-entry sign posted across the stars. But perhaps it's more than a wall. It's a safety rail, one that protects the universe from falling into paradox, chaos, and contradiction. If faster-than-light travel were possible, we could, in theory, violate causality, the bedrock rule that says causes must come before effects. Messages could be sent into the past. You could receive a reply before asking the question. A ship could arrive before it launched. These aren't just sci-fi problems. These are logical paradoxes that threaten the very idea of a stable universe. And so, light's speed limit isn't just a physical constraint. It's a kind of cosmic integrity check. It keeps reality coherent. It keeps stories straight. Now, that doesn't mean curiosity should stop. Far from it. Scientists continue to explore extreme frontiers. Quantum entanglement offers fascinating puzzles. Particles are entangled, states appear linked across vast distances. Measure one, and the other responds. It's tempting to think this means information traveled faster than light, but it didn't, because no usable information was transmitted. The effect is real, but not a message. And once again, light holds its crown as the fastest, most faithful messenger in the universe. Even our most daring concepts, like the Alcubier drive, a theoretical idea proposed by physicist Miguel Alcubier, which involves compressing space in front of a ship and expanding it behind, still require negative energy, something we don't have, can't make, and might never control. And even if such a drive existed, it wouldn't technically violate light speed. The ship itself wouldn't be moving through space faster than light. Instead, space itself would be moving, like surfing a wave of warped space-time. But again, the equations are full of red flags. Energy requirements are vast, and the paradoxes remain. So for now, and perhaps forever, light remains undefeated. It is not only the fastest traveler we know, but the most consistent, most predictable, and most deeply woven into the universe's logic. And in that, there's something oddly comforting. Because in a cosmos filled with chaos, exploding stars, collapsing voids, and the stretching fabric of space, there exists a single constant, a limit not born from limitation, but from wisdom. A rule that keeps the game fair, the timeline straight, and the future open. From Mars rovers and GPS satellites to black holes and wormholes, every exploration ultimately leads back to one glowing truth. Light is the great regulator. It whispers, "You may go fast, but never faster than me." And so we obey. Not out of defeat, but out of reverence. In our next episode on Infinity Beyond, we will explore the edge of light itself. What happens when light ceases to move freely? What if light is trapped, not just by gravity, but by the very nature of existence? We're heading toward the inside of a black hole, a place where light cannot return. Time may cease to exist, and the laws of physics tremble. Until then, keep dreaming, but remember, the stars may look close, but light has earned its head start.